Hi guys, so today we're gonna try LeetCode 2588, count the number of beautiful subarrays. So you're given a zero indexed integer array nums. In one operation you have to choose two different indices I and j, such that it is greater than or equals to 0 and lesser than nums.length, and choose a non-negative integer k such that the kth bit 0 indexed in the binary representation of nums I and nums j is 1. Subtract 2 to the power of k from nums I and nums j. Right, so non-negative integer k, so 1, 2, 3, such that the kth bit, so one of the bits in the binary representation of the number, are both 1. So they are both 1. So basically they have to have the same binary representation of k within the number. So a subarray is beautiful if it is possible to make all of its elements equal to 0 after applying the above operation any number of times. Return the number of beautiful subarrays in the array nums. So let's go to an example. Before we attempt this question, I would say that the code for this is quite straightforward. The difficulty is understanding the math behind it. So it's a math question. We're not going to write any code first. We're going to understand the mathematics deeply and fully before we go to the solution, which is using a bit of dynamic programming, which is not difficult to arrive at. So what I went ahead and did is I took this example 4, 3, 1, 2, 4, and I condensed it to this the binary representation. So how did I arrive at this? Okay, so 4 is 2 square. So basically the binary representation, if you're not familiar with that, you should go Google it, understand it. What it is basically you're trying to convert the number to a set of 2 powers. So in 4 is 2 square, in 3 is 2 to the power of 1, which is 2, plus 2 to the power of 0, which is 1. So that's 3. This is 1 because it's 2 to the power of 0. This is 2 to the power of 1, which is 2, 2 to the power of 2, which is 4. So the key to understanding this is that any number can be represented in this way, right? And what would constitute a beautiful subarray? When the number of 2 to the power of something in a certain range is equal in terms of it being in different numbers. Because you see in this example here, this is a beautiful subarray. You see 3, 1, 2 is a beautiful subarray. You subtract 2 to the power of 1, subtract this and this, you're left with this and this. Then you subtract this and this from these two numbers, and therefore they are all 0, right? Because this one becomes 0, this one becomes 1, this one is still 1, 0. This is also a beautiful this is also a beautiful subarray, the whole array, because you can subtract this, you can subtract this, and you know the middle part is a beautiful subarray. So there are 2 beautiful subarrays as a result. I hope you understood that. So the key operation that we need to understand apart from this is the OR operator, the XOR operator. So what does the XOR operator do exactly? What it does is that it finds the bits which are similar and it reduces them to 0 if they exist in both cases. So if in both cases it's an operator of 0, 0, which means that the bit does not exist, so there's no 2 power there. Say 2 power, in this case 2 power 2 is not present in both, right? Although it wouldn't even be there in a way. And okay, sorry, if it's either 2 power 1, in this case you can see it's not present. Sorry, XOR operator, what it does is it reduces those with powers in the same position to 0. So if it's 1, 1, okay, this is bad explanation, it becomes 0. If it's 0, 0, wait, let's just go to Wikipedia. XOR operator. Okay, so if input bits are the same, then it will be 0. If it's 0, 0, then it will be 0. But if it's 1, 0, it will be 1. Okay, so sorry about that. So in this case, if it was present in here but not present in here, this one will return just this value. So if you do an XOR of these two values, the values that are overlapping will disappear. in terms of the binary bits that exist. And that's all it is. So if you do an XOR of here, both, there'll be no change. You'll get, I mean not no change, you'll get basically this plus this. So that's basically the XOR operator in a nutshell. Okay, so the key to understanding how to use the XOR operator is this. When you have two values XOR together, say 4 XOR 4, or any two values which are identical, you get 0. Now why is this the case? The reason this is the case is because, remember, when they are the same, either 1 1 or 0 0, they both become 0. So both 4 4 will become 2's power square XOR 2 squared, right? So basically this removes both of the bits in the 2 position, and this becomes 0 effectively. So what you need to do, as you can see, so if you have this beautiful subarray of 4 4, it will XOR to 0. Now what if we have an example of 3 XOR 2 XOR 1, right? What will it equal to? Okay, and we have this case here, 3 1 2. Okay, it's a little bit different, 3 1 2, but it will lead to the same thing. Why? Right, because if you change it to this, and we already have it here, okay, I know where it's it may look a bit confusing because we're using power and XOR. So what we're going to do is we're going to reduce this, and we're going to reduce this to 0. So this one becomes like this, right? After 3 1 XOR, so it's basically 2, and then after that 2 XOR 2 will become 0, right? So that's basically why. So so long as the beautiful subarray is given an XORs to 0, then it will be 0 at the end. So what we need to do at the start is we need to create a dictionary. So we'll call it count, doesn't matter. So at 0, we'll set it as 1. So this tracks for when the XOR sum is 0, right? So that's at the beginning, before there are any elements. So the moment we reach the end, if the XOR sum is 0, like it will be in this case, because 4 XOR 4 equals to 0, 3 XOR 1 XOR 2 equals to 0, so 4 XOR 0 is 4, because there are no common positions between 0 and 4. So the 4 thing will remain in an XOR situation, right? Because of this 1 0 when it's not common. And then like when it's 4 XOR 4, it becomes 0 again. So when it reaches the end, then this thing will be added. And as we iterate through the array, we need to calculate the new XOR sum at that moment in time. And we need to check whenever it has already, the XOR sum has already appeared, it means that the values in between that point and the last point where the XOR sum appeared is actually a beautiful subarray. That's it. So I'll say it again. The reason we need to create this the reason we need to create this dictionary is as we are adding values to this dictionary, we are calculating the XOR sum. Not the XOR sum, but like the XOR value at a particular moment in the array. And the moment we find a value that has already happened previously, we know that the last time that the value has happened, the values in between the current value and that value is a beautiful subarray. So therefore, that will add 1 to the result. So if we go through this example, so it's 0, then now it's 4. So 4 is 1. Then now we're at 3. So the XOR of 4 and 3 should be 6, I think, because to be honest, I'm not 100% sure. I think it's 7 actually. Not too sure. Then it goes to 2, and then I think it's 6. Oops, sorry, by the way, it should be 1. And then it goes to 1, then it's 6, then it goes to 2, which is 2 power 1. Then 6 is basically this plus this, 2 power 1 is removed, so it's 4 again, right? So now the result adds 1, right? Why at 2? Because now the XOR sum is 4, and that's already appeared here, so actually now this 4 should be 2, but before it's added, when it's 1, you will add the result. I'll say it again, when it's 1, you will add the result, because you already know, at the XOR sum at 2 is 4. So 4 has already appeared. So all the elements between 4 and this XOR sum at 2 is a beautiful subarray. So result plus 1, 4, 2. Then it goes to, so right now it's at 4. It goes to 4 again, XOR becomes 0. So now, 0. You know what I mean? So you add result plus equals to 2 and 0 equals to 2 as well. So basically you increment this number as well, because the next time you get to this position, you will add that to the result. So in this case, the result is 2. So how do we code this up? So now I'm sure if you understood it, you can pause the video and go and try it out yourself. But if you didn't understand it, or rather if you just want to see out this video, or if you just want to get a possible way to implement this yourself, I mean, if you want an example code. Okay, so let's just print it, make sure that we're correct. Okay, counter, right? Let's hope this works. So result equals to 0 for a in nums. I think we can call this dp as well, because we're sort of caching it. And then result can be equals to 0. So those are the two variables we need. And then what we're gonna do is, first we're going to do this pre XOR sum, which equals to a. So we are also gonna initialize pre, which is 0, which is the XOR sum, because 0 is equals to 1, so that's before any values have been added, like I mentioned. And that's kind of what we needed to continue to calculate the pre XOR sum. Result plus equals to dp pre, and dp pre plus equals to 1. So the reason this is the case is because, like I said, we're going to need to add values from here. But before that, we first have to calculate the new value, because before it's 0, then at 4 the new XOR sum is 4, and then we're gonna have to add that if it's already appeared, etc, etc. So let's return result. Let's try. Looks like it's working. Let's submit this. Okay, so surprisingly the memory is really good, but the memory is in linear time, which is kind of strange, and the runtime is it's quite poor actually. Maybe there's not a lot of submissions, but anyways, it's in linear time. So yeah, the key to understanding this question, look, I know the video is about 13 minutes long. I spent more than 10 minutes going through the logic, because it's really what is challenging. And once you understand how to use the XOR operator and converting numbers to binaries, this question is not that complicated, and caching values. So yeah, I hope you enjoyed that. Thank you so much. Have a good day. Bye.